Now the iron ore and coke, along with limestone, are conveyed into the top of the furnace. Superheated air is blown into the bottom, elevating the furnace temperature to 4,000 degrees Fahrenheit and creating chemical reactions which form molten iron. Technicians carefully control and manage the operations from a highly automated control pulpit. Mission control for blast furnace operations. A robotic arm drills out a clay plug, causing a spectacle of cascading sparks, and the furnace is tapped. The molten iron flows into insulated bottle cars, which are transported via the mill's own railway to the next operation, steel making. At this point, the molten iron is not yet steel, so the contents of the bottle cars are poured into huge ladles and carefully transported by overhead crane to the basic oxygen furnace, or BOF, where the steel making begins. Before the molten iron is poured into the BOF, a load of scrap metal, a natural byproduct of the area's many automotive processing plants, is added for a mix of approximately 25% scrap and 75% molten iron. Pure oxygen is then blown into the mixture at more than 21,000 cubic feet per minute, removing the carbon, melting the scrap, and creating steel. The BOF vessel's molten steel contents are poured into a ladle capable of carrying 250 tons and brought to the LMF, or ladle metallurgy facility, where precision chemistries are produced. Electrodes are lowered into the ladle and the liquid steel is reheated while alloying elements are added to achieve the chemistry required by the customer. The process controls the chemistry, cleanliness, and temperature of the steel. Depending on the specific requirements of the steel, the ladle may be transferred to the neighboring vacuum degasser, which can produce ultra-low carbons of 0.01% and below. This process involves exposing the liquid steel to near absolute vacuum to produce steels with superior formability and increased strength to meet demanding applications. The next stop is casting, where the ladle is carried to one of the mill's two rotating turret continuous casters. The liquid steel is poured through a refractory shroud to an intermediate vessel called a tundish. As the steel flows downward from the tundish into the caster, water-cooled copper molds reduce the temperature and the steel begins to solidify into a solid block known as a slab. At the bottom of the copper mold, the 8-inch thick slab is further cooled by a fine water mist, and gas torches cut the slab to a length required by the customer order. The glowing hot slab is bar-coated before its journey continues to the hot mill.